Okay, here we have problem number 63. So we have 9 kg hanging object is connected by a light index tensible cord of a light frictionless pulley to a 5 kg block that is sliding on a flat table. Taking a coefficient of kinetic friction as 0.2, find the tension in the string. Now, the picture I'm going to draw it because it's here the picture is missing. So let me draw the picture. So in the picture, basically we have the flat surface. Okay. Here we have pulley. We have here our object. Okay. That object is connected to the by a rope, which is connected to the bigger mass. Okay. So let's call this one as m, small m. This one, let's call it as a big M. Okay. The mass of the small object is basically equal to 5 kg. The mass of the large object is equal to 9 kg. We also have that mu k kinetic friction, coefficient of kinetic friction is equal to 0.2. Okay. Now, in this problem, we have to find a tension. Okay. We have to find the tension. In order to solve this problem, we have to draw a free body diagram. So here we have a tension. Then here we have our mg. Then here we have kinetic friction, which is always oppose the motion. Okay. Then we have a normal force. Okay. Here, for the second object, we have a tension. Then here we have Fg, okay, which is capital M times G. By looking at this picture, we know that the object capital M is larger, so therefore we assume that it will be moving downward with an acceleration. Okay. We also have to define our direction. So if we define our direction like this, and we will say it as a positive. Okay. Now let's write down equation for separate boxes. For the first box, we can say that using the Newton's second law, sum of the forces is equal to ma. Now we're going to write down the equation for the small box. Okay. Whatever is pointing to the right will be a positive, and we already defined it, the direction of the acceleration. So we can say the sum of the forces, which is tension plus minus kinetic friction, that is equal to ma. Okay. Now, this kinetic friction is equal to coefficient of kinetic friction multiplied to the mg, which is equal to ma. Now, before moving on, let's find what is the gravitational, what is the weight of the small box. So the mass of the small box multiplied to the 9.8, and we should get that it's equal to 5 multiplied 9.8, which is 49 newtons. So our Fg for the small box, which is equal to 49 newtons. What about for big box? For the big box, we have 9 kilogram multiplied 9.8, which gives you 88.2 newtons. Okay. Let me just copy this. Okay, so let's continue. So we have written first equation for the small box. Now let's write down an equation for the bigger box. So for this one, we can say that the weight, or mg, capital Mg, in a positive direction, so therefore it's positive. Tension is in negative direction, so it means minus T, and equal to capital M multiplied to the acceleration. Okay, so we have now here two equations, which is this equation and second equation. In this equation, let's first find here acceleration, and once we find acceleration, we can substitute to any of these two equations, and we can find what it will be our tension. So the easiest way, by looking at this one, we can just add these two equations together. So when you add them, what you will get, the tensions will cancel out, right? So that means you will get capital Mg minus mu k mg is equal to ma plus capital Ma, right? So then we can say that our capital Mg minus mu k mg divided by small m plus capital M, which is equal to acceleration. Okay, now let's substitute the numbers. So our acceleration will be equal to our capital Mg was equal to 88.2 minus the coefficient of the kinetic friction is equal 0.2 multiplied our small mg was equal to 49. Then divided by small mass was 5 kilogram, big mass was 9 kilogram. Now, if you do calculation, you will find that your acceleration is equal 5.6 meter divided per second squared. Okay. Now we get acceleration. By substituting acceleration either on this one or that one, you will get the same tension. So let's just use the first equation. No, second equation better because it's less calculation. Okay, so for the second one, we can say that our capital Mg minus capital Ma is equal to the tension, right? So tension is equal, our capital Mg was equal 88.2 minus the mass of the big box is 9 kilogram multiplied our acceleration was 5.6. So let me do calculation. 88.2 minus 9 multiplied 5.6, which should give you 37.8 newtons. Okay, so this is how you find how you solve such a problem.